Next drugs are corticosteroids, so inhibitors of cytokine gene expressions. Okay, so example prednisone, methylprednisolone, dexamethasone. These are the drugs which have both anti-inflammatory and immunosuppressive property. Generally already you know that mechanism. Glucocorticoids went into the T lymphocytes. Glucocorticoids went into the T lymphocytes where they bind with glucocorticoid receptors. Later on, glucocorticoids receptor complex translocated to nucleus where they bind to DNA and inhibit the transcription of inflammatory genes, okay, cytokine genes. Okay, so once they bind with the DNA, the DNA, so that they inhibit the production of glucocorticoids receptor complex went to the DNA where they bind to DNA, glucocorticoid response element gene in the DNA. With this, there is a inhibit the expression of cytokine genes. So which cytokine genes? Interleukin 1, interleukin 2, interferon, and tumor necrosis factors. Okay, so these are all the cytokines which are responsible for T cell activation and proliferations. Okay, so with this there is a inhibit both cellular immunity and as well as the humoral immunity. So this is ultimate effect. Okay, so inhibit the gene expression of mRNA expression of cytokines, okay, related to cytokines interleukin 1, 2, interferons, TNF alpha. So with this there is no production of cytokines from the activated T lymphocytes. Okay, so once they inhibit, so further activation of other T lymphocytes, further proliferation of T lymphocytes is going to be stopped. Okay, is going to be not going to be processed, so that there is a decrease in the activation of T lymphocyte, cellular immunity and humoral immunity. Okay, so not only decrease the cytokines production, and also they have cytotoxic effect on the lymphoid tissue. This is the tissue where, so there is a production of T lymphocytes and B lymphocytes are happening. So these are the T lymphocytes, B lymphocytes are involved in the immunity system, so that they have also cytolytic effect on the lymphoid tissue. So with this there is a decrease in the circulatory number of T lymphocytes, okay, T lymphocytes and B lymphocytes. So is very important. Next, there is a third. Okay, first one is decreased cytokine production. Second one is decreasing the circulatory number of T lymphocytes. So third one is there is a suppress the antigen antibody reaction. So antigen antibody reaction is the this is the first step to initiate all the things. Okay, so which end with organ transplantation. So the third one is there is an inhibition of antigen antibody reactions. Okay, so this is about the thing. Okay, next is generally they are given by orally and parentally. Uses. Okay, so uses, they are used for treatment of organ transplant rejection and also used for treatment of autoimmune disorders like psoriasis, rheumatoid arthritis, lupus erythematosus syndrome, like SWAN. Okay, so these are the things on to all small organ transplant rejections. Okay, so side effects, so many side effects already we discussed. Okay, you can refer corticosteroids. Okay, next, other cytotoxic drugs. Okay, so other so after glucocorticoids, other cytotoxic drugs, examples inhibit purine and pyrimidine antimetabolites. Example, azathioprine, myclophenolate mofetil, so leflunomide and methotrexate, alkylating agents, right? So azathioprine. Okay, azathioprine and as well as the mercaptopurine both are same. Okay, means azathioprine is a prodrug, so which cleaved into mercaptopurine. Okay, so azathioprine is a prodrug of mercaptopurine. So already you know that mercaptopurine mechanism of action in the anti-cancer drugs. So the same mechanism of action applies to here also, but in the anti-cancer they stop the proliferation of cancer cells. Here there is a proliferation of T lymphocytes. Okay, so how they mainly inhibit the T lymphocytes proliferations. Okay, both T lymphocytes and as well as the B lymphocytes. Okay, I think you know clearly about mechanism of action of the azathioprine. Okay, see azathioprine. Let me. Okay. So here azathioprine converted into mercaptopurine. So this mercaptopurine converted into thioinosinic acid. Thioinosinic acid is a fraudulent nucleotide which is compete with the natural nucleotides, that is IMM, inosinic acid. With this there is a inhibition of production of nucleotides, pure nucleotides such as AMP and GMP. So with this there is no proliferation of the T lymphocytes and B lymphocytes. Okay, DNA for synthesis, proliferation of T lymphocytes, B lymphocytes required DNA replication is required. Okay, so whenever you stop the supply of nucleotides supplying for making of T lymphocytes DNA. So with this there is ultimately there is a stopping of proliferation of T lymphocytes and B lymphocytes happening. Okay, next same orally metabolism into mercaptopurine. Okay, so later on it is a and also converted into inactive metabolite, okay, by xanthine oxidase. Okay, so generally allopurinol generally use combined with azathioprine in order to prevent the toxicity and improve the efficacy of the azathioprine. Okay. Next uses, it is used for glomerulonephritis, systemic lupus erythematosus, rheumatoid arthritis, Crohn's disease. Adverse effects, already you know, generally whatever the adverse generally you may see in the anti-cancer drugs. So same thing, bone marrow suppressions. So with this there is a chances of leukopenia, thrombocytopenia, JD problem like nausea, vomiting, ulcers, liver toxicity, increased risk of infections. Next here I want to tell you about mycophenolate mofetyl. Mycophenolate mofetyl. So it is a semi-synthetic derivative of one of the natural drug, that is mycophenolic acid. Mycophenolic acid semi-synthetic derivative is mycophenolate mofetyl. What is mycophenolic acid? Is a there from fungus. Okay, so mycophenolate mofetyl is a prodrug. It is converted into mycophenolic acid. Okay, so mycophenolate mofetyl is a prodrug, is going to be hydrolyzed into mycophenolic acid. Mechanism of action of mycophenolate mofetyl. So there is a so there is a similar mechanism of action. You can observe with six azathioprine, sorry, six mercaptopurine are nothing but azathioprine and as well as the mycophenolate. Okay, what azathioprine can do is azathioprine will competitively inhibit the enzyme required for synthesis of both AMP and GMP. But this mycophenolate, especially it is works like same. Here especially it is inhibit the conversion of inosine monophosphate to xanthosine monophosphate, especially it inhibit the GMP. Okay, especially it inhibit the GMP productions. Okay, so mycophenolic acid is going to be inhibit the IMP dehydrogenase. IMP dehydrogenase is the enzyme which converts inosine monophosphate to xanthosine monophosphate. Xanthosine monophosphate converted into GMP. GMP converted to GTP. GTP converts to GDP. GDP converted to GTP. The GTP involved in the synthesis of both RNA and DNA, nucleic acids. Okay, so mechanism I will also. So this is nothing but de novo synthesis. De novo means it is a within the cell. Okay, they won't synthesize the one. Okay, de novo synthesis. Mycophenolic acid is a potent inhibitor of inosine monophosphate dehydrogenase. Okay, this is the crucial enzyme required for the synthesis of purine, one of the purine. What is the purine? Okay, so GMP. Okay, so deprivation of proliferation of both, okay, T lymphocytes and B lymphocytes. So it is only inactive drug converted into mycophenolic acid in the metabolism glucuranations. Okay, so again transplant resections. Okay, so combined with prednisolone, so no problem. Adverse effects majorly it cause leukopenia, neutropenia, lymphomas, cancer. Okay, GAT toxicity. So these are the side effects. Next is methotrexate. Okay, next is methotrexate. So methotrexate, it is a folic acid antagonist. You know that So folic acid antagonist, it inhibits the dihydrofolate reductase, so which is required for the conversion of dihydrofolate to tetrahydrofolate. So this tetrahydrofolic acid, it is involved in the synthesis of various purine and pyrimidine nucleotide. So with this there is a synthesis of DNA taken place. Not only DNA, RNA, protein, which are necessary for the T cell proliferation. DNA, RNA. So these are all the process happening in the T lymphocytes. Okay, please remember. So this mechanism of action is exhibited in the T lymphocytes or immunity cells, not in other cells. Okay, so that means the prime mechanism of so there is a chances of inhibition of other cells, so that which causes side effects. Okay, but in mind, okay, where they are working. So with, if you connect this, then easy to write the outcome. Okay, right? So ultimately what they do. Okay, so how they are linked to the immunosuppression. Okay, so inhibition of tetrahydrofolic acid, if tetrahydrofolic is not formed, there is no conversion of DUMP to DTMP. Okay, DTMP is a nucleotide involved in the DNA synthesis, like this. So there is an inhibition of purine nucleotide and pyrimidine nucleotide and protein synthesis. Okay, amino acid synthesis. So ultimately there is no production of DNA, RNA and proteins in the T lymphocytes. So ultimately causes interfere with the cellular proliferations. Okay, it causes immunosuppressive property. So same side effects is same as that you seen in the anti-cancer drug. Okay, so this is about already you discussed. Please refer that this thing. Okay, cyclophosphamide. Okay, cyclophosphamide, again mechanism of action same. Cyclophosphamide is a prodrug converted into phosphoramide mustard. It is alkylating agents. Okay, is going to be bind with, okay, it's going to be bind with DNA molecules present in the T lymphocytes. After that they interfere with the DNA function, they cause DNA destruction. So with this there is a destruction of proliferating T lymphocytes happening, destruction of proliferating lymphoid cells, so that there is no production of proliferating cells occur. Okay, so it causes suppress both cellular immunity and humoral immunity. Okay, side effects same as that of the drug. Okay, so this is about the major, okay, immunosuppressive drugs. So generally they ask in this only. Okay, if I required I will tell you other immunosuppressive drugs for important point. Okay, right? So with this I completed, okay, immunosuppressive drugs. So what are the major drugs we can concentrate in the immunosuppressive drugs? One is drugs which inhibit the interleukin 2 productions, like calcineurin inhibitors, like cyclosporin and tacrolimus. One more is sirolimus. Second one is steroids, glucocorticoids. Okay, if you don't if are unable to memorize these are the drugs which inhibit the interleukins 2 productions, you can cytokine production, you can directly write down corticosteroids like steroids like glucocorticoids. So next is cytotoxic drugs. Examples: pyrimidine and purine antagonist, azathioprine, and as well as the methotrexate. So next is alkylating agents, cyclophosphamide. Okay, so these are the drugs. With this I will complete. I completed immunosuppressive topic. Thank you. So if you have any doubt, so later on you can ask.